technique of tapping a single line of the service drop, grounding to the weatherhead, and jumping the meter socket to bring 120 volts into a new panel is extremely dangerous, illegal, and not an acceptable method. The reasons for this are manifold, covering safety, legal, and power company concerns. Firstly, the safety concerns are paramount. Contact with a live service drop wire presents an extremely high risk of severe electrical shock or even death. These wires carry substantial voltage and current and are not to be trifled with. Secondly, arcing or short circuits caused by improper connections could ignite a fire. The uncontrolled flow of electricity can generate intense heat, easily igniting nearby combustible materials. Thirdly, if other wires or objects are accidentally contacted, it can create a path for current to flow through the installer, resulting in electrocution. The human body is a conductor of electricity, and any accidental contact can have fatal consequences. Then, the legal concerns must be addressed. Unauthorized tampering with the electrical system without proper authorization from the power company is illegal in most jurisdictions. Electrical systems are regulated for safety and reliability, and unauthorized alterations undermine these regulations. Bypassing the meter to avoid paying for electricity is a form of meter tampering, which is also illegal. Electricity theft is a serious crime with significant penalties. The power company has serious concerns to take into account. Power companies prioritize safety and would not condone any unauthorized or unsafe practices on their distribution system. Their primary responsibility is to provide safe and reliable power to all customers. If an accident or injury occurs due to this practice, the power company could be held liable. They have a legal and ethical obligation to protect the public from harm. Improper connections could damage service drop wires, transformers, or other equipment owned by the power company. This can disrupt service to other customers and cost the power company significant money to repair. The proper procedure, if a service changeout requires overtime, is to coordinate with the power company to schedule a disconnect and reconnect, ensuring the safety of the installer and the integrity of the electrical system. This is the only safe and legal way to proceed. Electrical work should be performed by qualified and licensed electricians who are familiar with the National Electrical Code and local regulations. They have the training and experience to perform electrical work safely and correctly. Always use appropriate personal protective equipment, including insulated gloves, safety glasses, and appropriate clothing when working with electricity. This equipment helps to protect against electrical shock and other hazards. Never work on live electrical equipment unless absolutely necessary, and always follow lockout/tagout procedures to ensure that the power is turned off and cannot be accidentally turned back on. Lockout/tagout procedures are critical for preventing accidental energization of electrical equipment. If you are not qualified to perform electrical work, do not attempt it. Contact a qualified and licensed electrician to perform the work for you. It is always better to be safe than sorry when it comes to electricity. Electricity is a powerful force that can be dangerous if not handled properly. Always respect electricity and follow safety precautions to protect yourself and others from harm. Moreover, consider the potential long-term consequences of such a dangerous and illegal act. If discovered, the electrician could face severe penalties, including fines, loss of license, and even criminal charges. The homeowner could also face legal repercussions and be required to pay for the stolen electricity. In addition to the immediate dangers, there are potential long-term safety hazards associated with this type of makeshift connection. The improper wiring could create a fire hazard that could smolder undetected for months or even years before erupting into a full-blown fire. The consequences of such a fire could be devastating, resulting in property damage, injury, or even death. It is also important to remember that electrical systems are designed to operate within specific parameters. Tampering with the system can disrupt the flow of electricity and damage appliances and other electrical equipment. This can result in costly repairs and replacements. In conclusion, the technique described by the old-timer electrician is extremely dangerous, illegal, and not an acceptable method of bringing power to a home. It poses significant safety and legal risks and should never be attempted. Always follow proper procedures and coordinate with the power company to ensure the safety of the installer and the integrity of the electrical system. If anyone suggests such a shortcut, it is best to politely decline and insist on following the proper channels. There are no shortcuts when it comes to electrical safety. The potential consequences are simply too severe. When performing a service changeout, several key considerations ensure a safe and compliant installation. Firstly, a thorough inspection of the existing electrical system is essential. Identify any existing problems, such as damaged wiring, corroded connections, or outdated components. This allows for addressing these issues during the upgrade, ensuring a safer and more reliable system. Secondly, proper planning is crucial. Before starting the work, create a detailed plan that outlines the scope of the project, including the new service panel size, the location of the new equipment, and the wiring routes. This plan should comply with the National Electrical Code and local regulations. Thirdly, coordinate with the power company. Schedule a disconnect and reconnect of the electrical service with the power company. This ensures that the power is safely disconnected before starting the work and reconnected after the installation is complete. Fourthly, safety is paramount. Always wear appropriate personal protective equipment, including insulated gloves, safety glasses, and appropriate clothing. Work on de-energized circuits whenever possible, and use lockout/tagout procedures to prevent accidental energization. Fifthly, proper grounding is critical. Ensure that the new service panel is properly grounded according to the National Electrical Code. This provides a path for fault current to flow back to the source, protecting against electrical shock and equipment damage. Sixthly, use quality materials. Use only Underwriters Laboratories listed electrical components and wiring that are rated for the intended application. This ensures that the materials meet safety standards and will perform reliably. Seventhly, proper wiring techniques are essential. Follow the National Electrical Code guidelines for wiring methods, conductor sizing, and overcurrent protection. This ensures that the wiring is safe and will not overload the circuits. Eighthly, label all circuits. Clearly label all circuits in the new service panel with their corresponding loads. This makes it easier to identify and troubleshoot circuits in the future. Ninthly, inspection and testing are critical. After the installation is complete, thoroughly inspect and test the electrical system to ensure that it is working properly and is safe. Use a multimeter to verify voltage and current levels and check for any ground faults. Tenthly, documentation is essential. Keep a record of all work performed, including the new service panel size, wiring diagrams, and test results. This documentation will be helpful for future maintenance and troubleshooting. In addition, consider the following best practices for service changeouts. Firstly, upgrade to a larger service panel. If the existing service panel is undersized, upgrade to a larger panel to accommodate future electrical needs. This will prevent overloading the system and improve its reliability. Secondly, install surge protection. Install a surge protective device at the service panel to protect against voltage surges caused by lightning or other electrical disturbances. This can help to prevent damage to sensitive electronic equipment. Thirdly, use arc fault circuit interrupters. Use arc fault circuit interrupters on branch circuits that serve bedrooms, living rooms, and other areas where arc faults are more likely to occur. Arc fault circuit interrupters can detect and interrupt arc faults, which can cause fires. Fourthly, use ground fault circuit interrupters. Use ground fault circuit interrupters on branch circuits that serve bathrooms, kitchens, and other areas where ground faults are more likely to occur. Ground fault circuit interrupters can detect and interrupt ground faults, which can cause electrical shock. Fifthly, consider energy efficiency. When replacing electrical equipment, choose energy-efficient models to reduce energy consumption and save money on utility bills. This can also help to reduce the environmental impact of the electrical system. Sixthly, provide adequate lighting. Ensure that the work area is adequately lit to prevent accidents. Use temporary lighting if necessary. Seventhly, keep the work area clean. Keep the work area clean and free of debris to prevent tripping hazards and other accidents. Eighthly, communicate with the homeowner. Communicate with the homeowner throughout the service change-out process to keep them informed of the progress and to answer any questions they may have. Ninthly, follow all applicable codes and regulations. Ensure that all work is performed in accordance with the National Electrical Code and local regulations. Tenthly, obtain necessary permits. Obtain all necessary permits before starting the work. This ensures that the work is inspected and approved by the local authorities. Always prioritize safety, follow proper procedures, and coordinate with the power company to ensure a safe and successful service changeout. Electrical work should only be performed by qualified and licensed electricians. They have the training and experience to perform the work safely and correctly. Never attempt to perform electrical work if you are not qualified. It is always better to be safe than sorry when it comes to electricity. If the existing service drop is damaged or deteriorated, it should be replaced. The power company is typically responsible for replacing the service drop up to the point of attachment to the building. The service entrance conductors, which run from the point of attachment to the service panel, are the responsibility of the homeowner. If the service entrance conductors are damaged or deteriorated, they should be replaced by a qualified electrician. When selecting a new service panel, choose one that is large enough to accommodate the existing and future electrical loads. The service panel should have enough circuit breaker spaces to allow for all of the necessary circuits. It is also important to choose a service panel that is rated for the appropriate voltage and amperage. The service panel should be installed in a location that is readily accessible and protected from the weather. The service panel should also be installed in a location that is free from obstructions and that provides adequate ventilation. The wiring methods used for the service changeout should comply with the National Electrical Code and local regulations. The wiring should be properly sized, insulated, and protected from damage. The wiring should also be installed in a neat and workmanlike manner. The overcurrent protection devices used for the service changeout should comply with the National Electrical Code and local regulations. The overcurrent protection devices should be sized to protect the wiring and equipment from overloads and short circuits. The overcurrent protection devices should also be properly labeled. The grounding system used for the service changeout should comply with the National Electrical Code and local regulations. The grounding system should provide a path for fault current to flow back to the source, protecting against electrical shock and equipment damage. The grounding system should also be properly tested to ensure that it is working properly. The bonding system used for the service changeout should comply with the National Electrical Code and local regulations. The bonding system should connect all of the metal parts of the electrical system together, providing a path for fault current to flow back to the source. The bonding system should also be properly tested to ensure that it is working properly. The surge protection devices used for the service changeout should comply with the National Electrical Code and local regulations. The surge protection devices should protect against voltage surges caused by lightning or other electrical disturbances. The surge protection devices should also be properly installed and tested. The arc fault circuit interrupters used for the service changeout should comply with the National Electrical Code and local regulations. The arc fault circuit interrupters should detect and interrupt arc faults, which can cause fires. The arc fault circuit interrupters should also be properly installed and tested. The ground fault circuit interrupters used for the service changeout should comply with the National Electrical Code and local regulations. The ground fault circuit interrupters should detect and interrupt ground faults, which can cause electrical shock. The ground fault circuit interrupters should also be properly installed and tested. The energy-efficient equipment used for the service changeout should be under ITIS laboratories listed and rated for the intended application. The energy-efficient equipment should also be properly installed and maintained. The lighting used for the work area should be adequate to prevent accidents. The lighting should be properly installed and maintained. The work area should be kept clean and free of debris to prevent tripping hazards and other accidents. The homeowner should be kept informed of the progress of the service changeout and should be given the opportunity to ask questions. All applicable codes and regulations should be followed during the service changeout. All necessary permits should be obtained before starting the work. In addition, consider the following safety precautions when performing a service changeout. Firstly, always assume that electrical circuits are live until proven otherwise. Secondly, use a voltage tester to verify that circuits are de-energized before working on them. Thirdly, never work alone. Always have someone nearby who can assist you in case of an emergency. Fourthly, keep a safe distance from energized electrical equipment. Fifthly, never touch electrical equipment with wet hands. Sixthly, never wear metal jewelry when working on electrical equipment. Seventhly, never use a metal ladder when working on electrical equipment. Eighthly, never use a screwdriver or other tool to test for voltage. Ninthly, never overload electrical circuits. Tenthly, never run extension cords across walkways. Always use caution and follow safety procedures when working with electricity. Electricity is a powerful force that can be dangerous if not handled properly. If you are not qualified to perform electrical work, do not attempt it. Contact a qualified and licensed electrician to perform the work for you. It is always better to be safe than sorry when it comes to electricity. Consider the long-term benefits of a properly performed service changeout. A properly performed service changeout can improve the safety, reliability, and energy efficiency of the electrical system. It can also increase the value of the home. A properly performed service changeout can also help to prevent electrical fires and other electrical hazards. It is an investment in the safety and well-being of the family. Furthermore, a modern service panel can better accommodate the increasing electrical demands of today's homes, which often include numerous electronic devices and appliances. This prevents overloads and ensures that the electrical system can handle the load safely and efficiently. When selecting a licensed electrician for the service changeout, verify their qualifications and experience. Check their licensing status with the local authorities and ask for references from previous customers. A reputable electrician will be able to provide proof of insurance and bonding. Before hiring an electrician, obtain a written estimate that outlines the scope of the work, the materials to be used, and the total cost of the project. Compare estimates from several electricians to ensure that you are getting a fair price. During the service changeout, be sure to ask the electrician any questions you may have about the work being performed. A good electrician will be happy to explain the process and answer your questions. After the service changeout is complete, inspect the work carefully to ensure that it has been performed properly. If you have any concerns, contact the electrician immediately to have them addressed. Keep all documentation related to the service changeout, including the electrician's estimate, the permit, and the inspection report. This documentation will be helpful for future reference. Consider the environmental impact of the service changeout. Recycle old electrical equipment and materials whenever possible. This helps to reduce waste and conserve resources. Choose energy-efficient electrical equipment to reduce energy consumption and save money on utility bills. By following these guidelines, you can ensure that the service changeout is performed safely, properly, and in accordance with all applicable codes and regulations. This will improve the safety, reliability, and energy efficiency of the electrical system and protect the family from electrical hazards.